You see the ninth problem in the stoichiometry worksheet 3. So there is given 1.12 milliliter of a gas produced at STP. So by the action of 4.12 milligrams, it is given in terms of milligrams, it is in milliliters. Okay, alcohol with methyl magnesium iodide. So generally it is known as it is an example of a Grignard reagent. It is known as Grignard reagent. So no need to add it here now. So it is generally, or in the place of what methyl is there, the magnesium, this is halide. So here we don't need much details. The compound is given methyl magnesium iodide. So what is the molecular weight of that alcohol? So here we can conclude that the reaction of alcohol with methyl magnesium iodide giving a compound, okay, giving a gas. So how much? So we don't know the exact reaction, but we can conclude that here 1.2 milliliter of 1.12 milliliter. So convert it into liters. Okay. So 1.12 liters. So liters of gas produced by, so how many milligrams? So 1.12. So converted into grams, because molecular weight always indicated in terms of grams. That's why we are converting into in grams. So minus 3 gram of alcohol. Okay. So then what about 22.4 liter? So because we are calculating, just we are imagining that there is a formation of 1 mole of compound by 1 mole of alcohol. 1 mole of compound by 1 mole of alcohol. So here for 1 mole of compound, for 1 mole of the gas, 1 mole of alcohol is required. So we are calculating the what is the weight of that 1 mole of compound, which is equal to its molecular weight. Okay. So 22.4 liter of gas produced by how much alcohol? So this cross multiplication. So here's, so 412, okay, make it. So on this overall calculation, we will get, let's make it 11.2. So both are get cancelled. So on final calculation, we will get 82.4. Okay. So this is a minus 10. This becomes 10. Okay, 20, 80. Okay, it becomes 82.4. So the molecular weight of the alcohol means the mass of 1 mole of the alcohol we got 82.4. So directly we can say its molecular weight is 82.4. Okay. Let's see the question number 10. So here it is given 25.4 grams of iodine and 14.2 grams of chlorine yield a mixture of ICl and ICl3. So iodine 3 chlorine here. So in these compounds total halogens are present. This type of compounds are generally known as interhalogen compounds. The compounds which containing only halogens, the molecules formed between the two or more halogens, they are known as interhalogen compounds. So we have to find the number of moles of ICl and ICl3 in the reaction. So the reaction between I2 and Cl2, the reactants are given I2 and Cl2. So what are the products? The products are also mentioned ICl and ICl3. So easy to balance the reaction. 2 iodines, 4 chlorines. It's okay. We have to find about the number of moles of this ICl and ICl3. But here the information of I2 is given, information of chlorines are also given. So at that time, if the information of two reactants given, we have to find what is the limiting reagent. Okay. At first, according to the reaction, what is I2? What is I2 in terms of grams carbon direct? 1 mole means its molecular weight. 1 iodine 127. So that is 2 into 127, 254 grams. Okay, sorry. Means 254 grams of iodine react with chlorines. Okay, means how much? So 2 into Cl2 means that is 71. Okay, total how much? That is 142 gram. So 254 grams of iodine react with 142 grams of chlorine. So here it is what is a it is the question is asked in terms of moles, so very simple. So 1 mole of ICl, 1 mole of ICl3 are formed when these reactions, these amounts of compounds are reacted. But here how much iodine is given? So it is given 25.4 grams. So it is given 14.2 grams. Means this is also then by 10. So by 10 means here no exact limiting reagent, both are present in the perfect amounts. Okay, ఒకటి ఎక్స్ట్రా ఎక్సెస్ అమౌంట్ ఒకటి లెస్ అమౌంట్స్ లేదు ఇక్కడ. సో ఎగ్జాక్ట్లీ సేమ్ అమౌంట్ ఉంది. వచ్చి 254 reacts with 142 forming 1 mole of these compounds. Here it is given 254 by 10 means 225.4 grams is given. Here 142 grams reacted actually, but in the problem it is given 14.2. Means it is given by 10 times, it is given by 10 times, but we have to convert it in terms of moles. Okay. Okay. So here 254. So how much it is given? 25.4. So weight by what is the molecular weight? 254. So this is by 10. This is 1 by 10 moles. Okay. 0.1 moles is given. How much? This is also given, I think. So molecular weight 14.2. Molecular 1.2. This is also 0.1 mole. So here 1 mole gives 1 mole. In the same way 0.1 mole gives 0.1 mole. Sorry, 0.1 mole and 0.1 mole. Here we directly totally calculated for 2 moles. Okay. So it is also forms 0.1 moles. 0.1 moles of ICl and 0.1 moles of ICl3. Okay. So here one important thing you have to observe is here we got only 0.1 mole. It is not meaning so we done any calculation mistake. So it is actually we have to calculate it for only chlorine, then we will actually they are in 1:2 ratio. So 0.1 mole means here we have to get 0.2 moles. Okay, exactly we will get the 0.2 moles. Exactly we will get 0.2 moles only. But so what we done already, we calculated with this number of moles. If you take in about the normal about direct chlorine, okay, if you take the direct chlorine, that is how much? 71. Okay, so what is the weight? 14.2 grams of chlorine. What is the molecular weight? General molecular weight we know it is 71. So here we will get 0.1 moles. Okay, సో ఆల్రెడీ we calculated, ఆల్రెడీ మనం 2తో మల్టిప్లై చేసినాం కాబట్టి మనకు 0.1 వచ్చింది. అక్కడ ఆటోమేటిక్గా 2 into 0.1 చేస్తే 0.2 మోల్సే వస్తుంది. Okay, so like this also we do. They are in 1:2 ratio, they are in 1:1 ratio. 0.1 moles, 0.1 mole, 0.1 mole. Mean the answers are 0.1 mole of ICl, 0.1 mole of ICl3 are formed. Okay. Next. Okay, see the question number 11. So in the laboratory, a sample of urine. So we know that you must know about the urine formula. So in the laboratory, the urea test is a common one. So urine containing 0.120 grams of urea was treated. So that urea is reacted with the excess amount of this nitrous acid. So the gases formed was passed through aqueous sodium hydroxide. So the final volume is at STP. So what is this value? Means so after passing, means urine is treated with the excess of this nitrous acid. Urea is treated with the excess of nitrous acid. Some gases are formed. The gases products are passed over aqueous sodium hydroxide. Some gases are absorbed. So remaining some gases are there. We have to find out what are that gases. Okay, మొత్తం మీద ఫైనల్గా రిమైనింగ్ ఉన్న గ్యాస్ ఫైండ్ అవుట్ చేయాలి. సో మనకి మెనీ నెంబర్ ఆఫ్ గ్యాసెస్ ఫామ్ అవుతాయి. సో ఆక్వస్ NaOHలోంచి మనం పాస్ చేస్తే దెర్ ఈస్ సమ్ గ్యాసెస్ ఆర్ అబ్జార్బ్డ్. సో అబ్జార్బ్ అయిన తర్వాత రిమైనింగ్ ఫైనల్ వాల్యూమ్ ఆఫ్ ద గ్యాస్ మనం ఫైండ్ అవుట్ చేయాలి. ఓకే, సో ద రియాక్షన్ ఈజ్ ఆల్సో గివెన్ ఇన్ ద ప్రాబ్లమ్. So if it is not given, we have to know the reactions. In stoichiometric problems, the main thing is we have to know the reactions. So already in this problem, the reaction is given already. So there is a formation of carbon dioxide, nitrogen and water is there. Okay, so here which are present in the gases? Same, CO2 is the gas, it is the gas. So it is in aqueous medium. So this is a gas. Means we have to give the concentration on these two gases. Okay, so here the problem is, so here urea treated. So what is the molecular weight of urea? Here 60 grams. Okay, its molecular weight is 60. So urea, it is excess amount, no need to consider this. 60 grams of urea treated with 2 moles of nitrous acid. There is a formation of 1 mole carbon dioxide, 2 moles of nitrogen gas, 3 moles of water, and there is no need about the water because it is totally discussion about the gas released. The gas formed was passed through aqueous NaOH. And here important, we have to find out the CO2 gas or N2 gas. We have to know that. It is a conceptual. So if you pass these two gases over aqueous NaOH, the nitrogen gas is absorbed. In the place of sodium hydroxide, there is also this possibility giving potassium hydroxide. So the aqueous potassium hydroxide, aqueous sodium hydroxide natures ఏంటంటే they absorb the nitrogen gas. So here whatever the nitrogen is formed is released out. Released out means it is absorbed by NaOH. So remaining మిగిలిపోయిన gas ఏంటిది? What is the gas remained in the mixture after passing it through aqueous NaOH? Only about carbon dioxide. Means here we have to find about the volume of carbon dioxide formed. Okay, so here we write a point that excuse me. So the former nitrogen gas is absorbed by aqueous sodium hydroxide. So therefore finally the gas remained is only carbon dioxide. So we have to do the problem only for carbon dioxide. We have to find how much carbon dioxide will be released. See here again to this 60 gram releases 1 mole of CO2. According to the equation we know that 60 grams of urea release how much carbon dioxide. It is in terms of volume. 1 mole means 22.4 liter of carbon dioxide. Okay, then what about is given in the problem how much? I think 0.120 grams. 0.120 grams of urea release how much carbon dioxide? So here make it sorry, 2 into 22.4 here 44.8 into 10 power minus 3 liter of CO2. I think in the options it is given in terms of milliliters. So liters convert into milliliters, make it into 1000. This 10 power minus 3 becomes cancelled. So there is a milliliter of CO2. Milliliter nothing but cubic centimeters. So means in this problem we have to know the conceptual thing, that is the sodium hydroxide or potassium hydroxide generally absorbs nitrogen gas and not to the carbon dioxide gas. Okay. Okay, see the question number 13. So what is the volume of oxygen required for the complete combustion of a mixture of 5 cc methane, 5 cubic centimeter of methane and 5 cubic centimeter of ethene. This is also known as ethene or ethylene. Okay, so here important, so when the time comes to the mixture, generally we find which undergoes the reaction, but here 2R undergoes the complete combustion reaction. So we have to consider the both reactions and we have to work out for both reactions. So what is the reaction? The combustion reaction. In any hydrocarbons combustion, all hydrocarbons combustion gives carbon dioxide and water only. First we see about the methane. Okay, methane, this one carbon, four hydrogens, yeah, four oxygen. So methane, 1 mole methane required 2 moles of oxygen. First we calculate this problem, means so take it as case 1. So 1 mole it is given in terms of value. So 1 mole means how much? 22.4 liter of methane required how much oxygen for complete combustion? 2 moles. Here also have to find the volume of oxygen. So again volume converted 2 moles means 2 into 22.4 liter of oxygen. So and then what is the question? So the question is 5 cc, 5 cubic centimeters means 5 milliliter. So I am converting into liters. 5 into 10 power minus 3 liters of methane need how much oxygen? This cross multiplication. Okay, this is How much we are getting? 4 liters. Here 22.4 liters only. So here we are getting, so 10 into 10 power minus 3, so that is equal to 10 power minus 2, that is nothing but 0.01 liter. Okay, 0.01 liters of oxygen is required for this. Okay, next we calculate 0.01 liter means I think in the options it is given in terms. Okay, first we calculate in terms of liter, finally we compare the options. So next we have see the reaction of C2H4. So take the case 2. Okay, the reaction of C2H4, it is also hydrocarbon. Hydrocarbons combustion, always there is a formation of carbon dioxide and water only. Okay, 2 carbons make it 2 carbons. Here 4 hydrogens make it 4 hydrogens. Now how many carbons? So oxygens 4, 6. So make it 2. So here 1 mole required 3 moles, but total in terms of volumes property, here we can write 22.4 liter of C2H4 need how much oxygen? 3 moles. 3 into 22.4 liter of oxygen. So we have to find so how much it is given in the problem. It is given 5 cc, 5 milliliters. I am converting it into milliliters, so liters. 5 to 10 power minus 3 liters of C2H4 need how much oxygen? So this is by getting 15 into 10 power minus 3 liters, or we can say, okay, so total how much, convert it into milliliters. Okay, so I think that if the answer is given in liters, we can say this 15 liters, this is 0.01 liters. How much we will get finally? Total oxygen need. So for the combustion of methane and ethene, okay, methane and ethene is so 15 into 10 power minus 3 liters and 0.01 liters. So finally we will get how much? So on general calculation, here we will get to 10 power minus 3. Here only 10 power minus 2 is there. So just common the 10 power minus 2. Here we will get how much? Minus 1 plus 1. So here 1.5 into 1 2.5. So we can make it as a 25 into 10 power minus 3 liters. So the answer in terms of liters is 25 into 10 power minus 3 liters. I think in the options it is given in terms of milliliters. So convert this liters into milliliters. Liter, 1 liter equal how many? 1000 milliliters. So finally we will get 25 milliliters, nothing but cubic centimeters. Okay, means here also have to know the reactions. Okay, see the question number 14. So actually it is also a very simple problem. So but the reaction is how to remember. So lactose is commonly used as a binder in the tablets. Okay, so lactose is also so very important carbohydrate. So has a molecular formula, molecular weight 342. We have to find what is the weight of carbon dioxide formed when 1 by 12 moles of this compound is burnt completely. Mean here important what is the formula of lactose. So we know the formula of sucrose, that is C12H22O11. In the same way the formula of lactose is also C12H22O11. Just like glucose, fructose are having same molecular formula C6H12O6. In the same way, so maltose, lactose and maltose, lactose, sucrose, the three are having same molecular formula C12H22O11. Now we see it's burning. So it's burning means nothing but with excess oxygen. So C6H12O6 one. So sucrose formula, lactose also, sucrose, maltose same. That is C12H22O11 with excess oxygen. So it forms again carbon dioxide and water. Same here, 12 carbons. So 12 carbons. How many hydrogens? 22 hydrogens, make it 11. So how many oxygens we are having? 24, 11. Okay. So 25. So if you get here 12, so 35. Okay, 24, 34. So here 1 mole of glucose, sorry, not glucose, 1 mole of lactose. 1 mole of lactose reacts with the how much? 12 moles of oxygen. But here we have to know the relation between carbon dioxide and lactose. No need of about oxygen. We have to know about the carbon dioxide. 12 moles of carbon dioxide means for 1 mole of from 1 mole of lactose combustion we are getting 12 moles of carbon dioxide. But here it is given in terms of moles, it's okay, but it is given in terms of weight, means in terms of mass. So here we can write a sentence that is 1 mole of lactose, 1 mole of lactose produce how much carbon dioxide? 12 into 44 grams of carbon dioxide, because we want to know the carbon dioxide in terms of mass. Then what about 1 by 12 moles? Sorry, the question is 1 by 12 moles of lactose produce how much CO2? Very simple. Just by knowing the reaction, it's become very simple. But always in the problem they do not give the chemical equation. So finally we will get 44 grams. Only 44 grams of carbon dioxide. So directly also we can say it is in the ratio of 1:12. So 1:12 means it's 1 by 12 It is by 12 means we'll get only 1 mole. So if it is if on very practice you will we are able to do the calculations directly. So I see 1 mole releases 12 moles. 1 by 12 moles releases 12 by 12 means 1 mole. 1 mole under its molecular weight 44 grams. Okay. So see the 15th one. So it is given how many moles of hydrogen would be required for the complete hydrogenation of 0.5 moles of 1,3 butadiene. So actually the problem is okay in our syllabus, but actually the name is out of our syllabus. So 1,3 butadiene is an organic name. So organic compound means, so what is that compound is 1,3 butadiene. The compound is like this. So this is the 1,3 butadiene. So on its complete hydrogenation. So complete hydrogenation means unsaturated compound. Unsaturated compounds means unsaturated compounds which is having the double bonds or triple bonds between the carbons. That unsaturated becomes saturated. Saturated means the carbon atoms are having only single bonds around them. Okay. See, this becomes so on complete hydrogenation means all double bonds becomes only single bonds. So then the compound becomes like this, and is writing this compound we have to maintain that each carbon must having 4 sigma bonds around it. Okay, in saturated compound here also each carbon is having 4 bonds, but some double bonds are there. We know that in the double bond one single bond is there, one pi bond is there. In saturated compound means on complete hydrogenation only single bonds are present between the carbon atoms. So totally how many hydrogens are become extra? So that much of hydrogen should be required. So for 1 mole we are calculating here. So what is the formula of this? 1, 2, 3, 4, 4 carbons. How many hydrogens? 2, 3, 4, 5, 6. So C4H6. Then what about this? It becomes how much? 4 carbons, 3, 4, 5, 6, 7, 10. C4H10. How many hydrogens are extra? 2 extra. Sorry, 2 H2s means 2 moles of hydrogen. That becomes 2 to the 4, this is 10. Means there is a requirement of 2 moles of hydrogen. But here for 1 mole. So this reaction is for 1 mole of this compound. 1 mole of 1,3 butadiene requires 2 moles of hydrogen for complete hydrogenation. But what about it is the question is just for 0.5 mole. So 0.5 mole means so 1 mole. 1 mole 1,3 butadiene need 2 moles of hydrogen. Hydrogen means we have to take H2 only. 2 moles of hydrogen. So for complete hydrogenation, so then this what is 0.5 mole? 0.5 mole is obviously by 2. Okay. Need how many moles of hydrogen? That is equal to 1. That is 1 moles of hydrogen is required. 1 moles of hydrogen is required for the 0.5 mole of complete hydrogenation reaction. Let's see the question number 16. It's a very simple problem. So, but it is only the one problem. It's very simple in this worksheet. So, I also want to explain this again. So, which of the fertilizers is the richest nitrogen source. Generally, we know what is the main use of nitrogen is it is a major component in the all types of fertilizers. We are given four types of fertilizers. We have to find in which the percentage of nitrogen by mass is richest. Means the percentage of nitrogen is highest in terms of mass. So we calculate it to one by one. Okay. So here what is the nitrogen? So nitrogen, two nitrogens are there. Okay, it's a 28 nitrogen part 28. Four hydrogens, it's a 48. So how much we are getting? I think it's 80 grams. Okay, it's molecular weight 80. So what is the percentage of nitrogen? Percentage of nitrogen in it is so amount of nitrogen by total weight into 100. So how much we are getting? So approximately just we are getting 35%. So we are getting so 35 percentage of nitrogen only. Okay. Okay. Next, calculating NH4 taken to see. Actually, we don't know the exact names of these compounds. So we know this one, this ammonium nitrate. So here ammonium carbonyl compound. So again, two nitrogens are there. 28. So 8 hydrogens are there. So the overall molecular weight we are getting, so it's a 64. Okay, 16 4 so this is 64. So in this we have to find the percentage of nitrogen equal to, so 28 by, so what is the total? 64 into 100. Okay, so on this overall calculation we are getting 0.4375 in this calculation. Here we get 43.75%. We have to compare the percentages of nitrogen in all compounds. Okay, so in NH3, NH3 looks very simple. So nitrogen 14, hydrogen 3, total 17. So the percentage of nitrogen equals 14 grams in 17. It appears a very high percentage. So it gives 0.8235. So finally, ammonium sulfate. So here we are doing the calculation. Ammonium, 2 nitrogens, 8 hydrogens, sulfur 32, oxygen 4 oxygens. So total we will get 14. So 132. So what is the percentage of nitrogen equal? When the percentage of nitrogen we get so 28. So it appears very less percent, because 132 grams there is only 28 grams is there. So here we will get 21.21. Means in which we are getting the highest percentage. The first we are getting 35%, here 43%, here 82%. This is the highest. So third is the option. In ammonia there is a nearly 82.5 percentage of nitrogen is there. Okay, see the one more question. Actually we left this question. So it's also very simple. If 2 moles of ethyl alcohol are burnt, the amount of CO2 formed will be. So here the reaction is very important. The burning of ethyl alcohol. Burning means It takes place in the presence of oxygen only. Okay. So it releases CO2, H2. It is particularly given 2 moles of ethyl alcohol. We have to take 2 moles. Here's a 4 moles of CO2. So what about oxygen? Have to balance the reaction at first. So how many hydrogens are there? So 6. Here 10, 12. So 6. See the oxygens. It's 14 are there. Here only 2 oxygens are there. 16. Okay. Now 2 moles of ethyl alcohol forms 4 moles of carbon dioxide. So very simple. 2 moles forms 4 moles of carbon dioxide. So 2 moles is 4 moles of carbon dioxide means 4 moles weight equal how much? Is carbon dioxide 44. So there is a 176 grams. So I think the option 4th is the correct one. There is a 176 grams of carbon dioxide is formed. On 1 mole we are getting only 2 moles of CO2. Here particularly it is mentioned 2 moles. From 2 moles it is 4 moles of carbon dioxide is released. So here important thing is so maximum the total 16 problems are there in the worksheet 3. We explain the total 16 problems because there is somewhat difficulties there. So but we completed our duty. It is your duty to practice it for many times, minimum 5 to 6 times you have to practice these problems. Okay.